So in this video, we're going to go through quantum teleportation. So one of the things that we can do with quantum particles is teleport them between two locations. So suppose we have, say, Alice's lab. Alice lab, this is her lab right there, and she's going to want to teleport a bit to Bob's lab. So she has some state right here. Let's say psi is equal to alpha up plus beta down. That's what she wants to teleport over to Bob's lab. Now she does not know alpha and she does not know beta. If she tried to measure alpha or beta, she couldn't anyway. She'd have to have a whole bunch of them, and then this is just an average. When you square that, that's the average of your ups. But she would also destroy the bit if she tried to even measure it. So here, down below here, we've got Bob's lab. Bob's lab is down here somewhere. Let's just say right here is Bob's lab. So she'd like to transfer that bit to Bob's lab without affecting it at all. But one thing that they do have to share if they want to teleport something, they have to share a Bell state or a quantum entangled state. So here is a quantum entangled state right here, between here and here. There's the quantum entangled state. And the quantum entangled state I'm going to use is the 1 over the square root of 2 up, plus 1 over the square root of 2 down. That's a quantum entangled state. So this up right here, the first ups correspond to this one, and the second up and down correspond to this one down here. So these are my I have 3 particles right here. They're right there. Okay. Now, we might say at this point right here, we have what is the state of the system right here. Let me call this it. Let me bring this up a little bit just so I can keep the space here. This is at 1, location 1 right here. The first bit is alpha up plus beta down. So that's the first bit, and then these two are tied together, which is that 1 over the square root of 2 up plus 1 over the square root of 2 down. So that right here at point 1 right here is what the system is at. And I could tensor multiply those together. Might as well tensor multiply those. What does that give me? That gives me alpha over the square root of 2 up. Remember, the first one is this one, the second one corresponds to that one, and the third one corresponds to this one. Plus alpha over the square root of 2 up, down. The square root of 2 up, down. Plus this one times this one, beta over the square root of 2 down, up. Beta over the square root of 2 down, up. Plus beta over the square root of 2, down. Down. So that's what the system is right here at this point. Okay, so what is Alice going to do with one of her bits? She's going to do, remember, these were our gates. These are only 3 gates we'll need. The C naught, which says if the first one is an up, don't do anything to this. If this is a down, then turn the ups to downs and downs to up. This one up here didn't do anything to up, turned down to minus down. This one up here turned up to downs and down to ups. So what's she going to do with this bit right here? She's just going to do a C knot between this one and this one right there. That's what she's going to do. Between the first two bits right here. So what does that do to this right here? Well, if the first bit is an up, don't do anything to the second bit. If the first bit is a down, flip the second one. Don't do anything to the third. We're not changing anything. So at this point, we'll be at 2. So at number 2, this is number 1 right up here. Now we're at 2. What are we going to do? Since the first bit is an up, we're not going to touch the second bit. Since this is an up, we're not going to touch that bit. Since this is a down, we're going to flip that. So it's going to become down, down, up. And since this is a down, we're going to flip the second one. So it's down, up, down. So our whole thing then becomes, at number 2, it becomes alpha over square root of 2. Up, up, up. Plus, and the second one we kept the same 2, alpha over the square root of 2, up, down, down, plus beta over the square root of 2. Now we said, since this is a down, that flips this to an up, the second one. So that becomes down, down, up. And then the last one was beta over the square root of 2. Since this is a down, it flips that to down, up, down. Okay, so now we're at number 2 right here. Now, Alice is going to measure this one right here. She's going to measure it. Maybe I'll draw it like this, a little needle or something. She's going to measure it right there. She's going to measure it, and what is she going to either measure, up or down, right here. And then, when she measures it, she gets on the phone and she calls Bob. So after you measure it, then you call Bob. Okay. Now, as soon as she measures it, what's that going to do right here? Well, it depends on what she measures right here. Remember, this was the state before. Now she measures it. Let's just say she measures up. So let's just say Alice measures up. Alice measures up. Well, that would mean that the second state, that means that this guy got taken away because we know it's not the down and we know it's not that one. Sorry, we're over here on this one right here. Since she's measuring the second state, if she measures up, that means she's only going to get these two states right here. We can get rid of the middle up because she measured the up. So the state would be alpha over the square root of 2, up, up. So we would have 1 over the alpha over the square root of 2, up, up. You get rid of the 1. So this is the first and the third one. Not that one, not that one. And then you get plus beta over the square root of 2, down, down. Plus beta over the square root of 2, down, down. So that's what the state would be if she measured up. If she measured down, if Alice measures, she's got to measure one or the other, down, well then it just goes to this state and that state right here, because that's the one where the middle one was down. So it'd be alpha over the square root of 2, got rid of the middle one right here, and that is up, down, up, down, plus, we're doing the one where the middle one is down. It'd be this one, beta over the square root of 2, down, up. Beta over the square root of 2, down, up. Okay, those would be whatever they were right here. So now, what's Bob going to do? Bob is going to say, well, if you told me it was up, I'm not going to do anything. If you tell me it was down, then I'm going to put an X gate here. So this is X gate only if Alice says it was down. So if down, then I'll put that X gate in there. Okay, so what would it be? This one's gone, we've already measured it away, so we've only got the first and the third one. What would the X gate do? Now, Bob is only going to do it if it's in this case, when it's in the down. And so what is he doing? He's going to flip, remember that turns ups to downs and downs to up, but it's only in the third bit. The last one right here. So it's going to turn that into an up, and it's going to turn that one into a down. So right here at this point, we'll call that number 3, right there. Well, you notice at number 3, we have this for the one case. In the other case, it's this through the X gate on the third one, which is alpha over the square root of 2, up, plus beta over the square root of 2, down. Which is the same thing. So now we're back to the same thing for number 3 right here. We know what the state is. It's alpha over the square root of 2, up, plus beta all over the square root of 2, down. Okay, so that's what it is at that point, number 3. So now what Bob's going to do is he's going to turn his instrument sideways, right here, our sensor. Remember we had our sensor look something like this, and measure whether it's right or left. So he wants to measure rightness or leftness. So he wants to measure, this is Alice, wants to measure right or left. Is it right or is it left? And that's only on the first bit. So it's only on the first bit right here. Well, what I should do for these two right there is turn them into rights and lefts, because then I'll know what you get. So I'm going to turn this up into our right and left. We know that up is equal to 1 over the square root of 2 right, plus 1 over the square root of 2 left. And we know down is 1 over the square root of 2 right, minus 1 over the square root of 2 left. So I'm going to replace this one. I'll keep that one as up. So we got alpha over the square root of 2. Now this one, this first up, we'll turn it into this, 1 over the square root of 2, right, plus 1 over the square root of 2, left. And we still have that second up, plus beta over the square root of 2, we've got the down. The down is this one right here, 1 over the square root of 2 right, minus 1 over the square root of 2 left. And that gives me, we still have the extra down on there, down. Okay. So, what I should do is, remember this is really a right up and a left up and a right down and a left down. I'm going to factor out, maybe I'm going to factor out the right here. I'm going to, out of this two terms, I'm going to factor out the right. Out of these two terms, and I'll factor out the left out of those two terms. So what's left with the right? If I factor it out, I got alpha over 2. I think I'll pull out the 2. So I'll pull out the 2. And I got an alpha up. I got an alpha up. And then pulling out the R out of this one and pulling out the 2, we got a plus a beta down. Okay, so that's pulling the right out. And then we have to still have the left term also, plus the left all over 2. So if we pull out the left over 2, we got an alpha up. Okay, and then we got the last term here. We got this term right here. We already pulled out the half. We have a minus beta down. Minus beta down. Okay. So now we have, this is what it would be right here. We could call that to 4. 4. Actually, it's not 4 yet. It's still 3. We haven't made the measurement. We've just changed the base, so we haven't done anything yet. Right here. This is still the state. Now we want to make this as a measurement right here, because you're going to read something off of there. So if we read something off of there, so you're going to read this. How can I write it? I guess I could write it like this. Again, some needle. I'm reading. And what she's going to, what Alice is going to do is she's going to call Bob again. It's a 2 phone call thing. Call Bob. Okay. And tell Bob what you got right here. If you call, if Alice calls Bob and says, I got a right, then we know this is the state. If she says, I got a left, then this is the state. So after the phone call, if she says, I got a right, then the state of the system is alpha up plus beta down. If, I don't need the 2 in there because this is all normalized anyway by now, right here. If she says I got a left, then it's going to be that one over there. Alpha up minus beta down. Okay, well, if she tells Bob that she got it right, then Bob's not going to do anything. But if you get a left, then Bob's going to put it through a Z. If left. Only if left. Well, so with this one, it won't do anything to it. If it's right, you just keep it the same. Alpha up plus beta down. If it's left, then you're just going to put that through the Z gate. Remember what the Z gate does. It doesn't do anything to ups, but it turns downs to minus downs. So it won't do anything to the up, but it'll turn that down and make this a plus. So it becomes alpha up plus beta down, which is the same thing. Now they agree on the state right there. Not only that, that state is the same state that this was. It used to be in Alice's lab. This now, right here, is below everything below here is in Bob's lab, so this is all in Bob's lab right here. So that last bit right here, this right here, which is this, is now in Bob's lab. So they were able to teleport this bit without even knowing what alpha and beta are from Alice's lab to Bob's lab right here. So this is teleportation. It's been done over short distances right here for, I don't know how many bits, maybe whether they've done it for a few bits, but you'll notice that you're not going to be doing it for people for, I don't know if you could ever do it this way with people, because for each particle I need a quantum entangled particle. You'd have to have as many quantum entangled particles as you have atoms in a body right here, which would be a lot right there. So not only that, you'll notice I had to destroy this to create this. So you'll notice on Star Trek when they beam up, they have to destroy the person going into the teleporter to create a new person outside. So that's just no cloning theorem. You can't create a copy of it. So this is teleportation right here. And so what we're going to get into next right here is, so far everything's been on bits. We were thinking of these almost like a coin toss right here, or heads or tails. But now we're going to say, I don't think about the heads or tails. I want to think about where the coin is right here. So we never thought about where things are. We just cared about heads or tails or ups and downs. But now we're going to look at where is the particle.